star's life cycle is determined by its mass. The larger its mass, the shorter its life cycle. This is the life cycle of a star, 10 times the mass of our Sun. A star is born in a region of a high-density stellar nebula. The young star condenses into a large globule of gas and dust and begins to contract under its own gravity. At the beginning of its life, the star is only 5,000 degrees Kelvin and appears to be yellow. As the star ages, this region of condensed matter begins to heat up and glow, forming a protostar. Since the star is so massive, its central temperature reaches about 10,000 degrees Kelvin. At this temperature, hydrogen begins to fuse, producing helium, which creates energy. The main sequence stage is the longest phase that a star will go through, around 20 million years. As the star fuses more hydrogen, it releases more energy. This stops the star from contracting even more under its own gravity. This star, having a 10 times greater mass than the Sun, will fuse hydrogen and use up its energy even more quickly. The temperature at this stage is approximately 22,000 degrees Kelvin and can appear to be more blue due to its much greater heat and energy emission. Once the star begins to run out of hydrogen, it enters the phase of being a red giant. Without any more hydrogen to fuse into helium, it contracts under the force of its own gravity, which causes the core to heat up and fuse the helium into carbon. The outer layers of the star expand, cool, and shine less brightly, returning to a temperature of around 6,000 degrees Kelvin, similar to its temperature at the beginning of its life. This expansion continues as the star becomes a red supergiant. The star continues to cool and is approximately 4,500 degrees Kelvin. As the helium begins to run out, gravity takes hold of the star, causing a massive explosion as the star's core collapses. This is called a supernova, which can shine brighter than the entire galaxy for a short time. The amount of energy and heat that this explosion produces is almost immeasurable, reaching a temperature of about 100 billion degrees Kelvin. After this massive explosion, the force of gravity overcomes the nuclear forces which keep the protons and neutrons from combining. The core is then swallowed by its own gravity, thus turning it into a black hole, which will consume any matter or energy that comes within close proximity.